Laplace transform, or in short, means it is a short form, Laplace transform. You can say Laplace transformation. So see, Laplace transformation of a function ft, which is defined for t greater than equals to 0. What is that? So here actually we are going to find a transform, one kind of transform of a function. So we are assuming a function ft, which is defined for t greater equals to 0. Means in the positive real axis, the function is defined. Okay. Then Laplace transform of this function, it is denoted as L of ft. Okay. Laplace transform notation, it is L of ft. Now how to find or how to evaluate that Laplace transform? And that Laplace transform, it is basically an integral which is of the form 0 to infinity e to the power minus st ft dt. Okay, so that is the formula, basic formula for Laplace transformation. Given ft, if it is asked to find Laplace transform of ft, you have to evaluate that integration 0 to infinity e to the power minus st ft dt. Now, if you evaluate this integral, will it be a constant or anything else?
Something else.
Yes, means here I am telling about s. Now I have given e to the power minus st, where s is a parameter. Okay, so if you evaluate it, it will be a function of s, is not it?
Yes.
Yes, sir.
So that is why that Laplace transform also can be denoted as capital F of s. Okay, means it is a function of s. Basically, we are taking a Laplace transform of function which is a function of t, and after taking the transform, it will be a function of s. So it is one kind of mapping actually. It is one kind of mapping where the domain consists of some function of t. Okay, and after taking this transformation, it gives us a function of s. So it is one kind of transform from a function to another function. Now, okay, it is called Laplace transformation. F T. Okay. Now you should be careful about the notation. So what kind of notation? Means whenever we are taking Laplace transform of small f, okay, so it is small f. After taking the transformation, we are denoting it as capital X. So there have a relation between that. Means that is a means for our uh, beneficial we are taking this. Means the function, initial function, it is in smaller case or lower case, and its Laplace transform, it is denoted by its uppercase. Okay, small f and capital F. So these are the notations for this is the notation for Laplace transform. Laplace transform, it is denoted as capital Fs or L of bracket Ft, and it is defined as the integral 0 to infinity e to the power minus st ft dt. Fine. So for some example, if ft is equal to say 1, ft is equal to 1, given ft is equal to 1, which is defined for t greater than equals to 0, means ft is equal to 1 means what? It is parallel to x axis, is not it? Means this type of graph, this type of graph, right? That is t ft. It is ft equals to 1, t greater equals to 0. Now only for that portion, whenever t greater equals to 0, if it is asked what is the Laplace transform of that function, so Laplace transform of ft, how to find it? You apply the definition, that is Laplace transform of 1. So according to the definition, it is 0 to infinity e to the power minus st into what? ft1.
Yes, sir.
This integration 0 to infinity e to the power minus st into 1 dt, and which is equals to, now you integrate it, uh, it is simply e to the power minus st by minus s, right? Zero to infinity. Now if you put infinity, it is what? If you put t is equal to, here the this value 0 and infinity, these are value of t. So if you put t is equal to infinity, then it will be e to the power what? Minus infinity, provided s is positive, is not it?
Yes, sir.
So if s is positive, then e to the power minus infinity, that is 0. So 0 and minus, if you put t is equal to 0, then it is minus 1 by s, which is equals to 1 by s, provided what? S greater than 0. S greater than 0, that is why e to the power minus st, uh, t tends to infinity, it is 0. Na? So what we are getting, that Laplace transform of the function 1, Laplace transform of the function 1, it is 1 by s. Okay. Similarly, we can take any other, uh, like this, if t is equal to say e to the power 3t, okay, e to the power 3t, then what is the Laplace transform of this function? So Laplace transform of e to the power 3t, okay, and it is equals to, by the definition, 0 to infinity e to the power minus st into ft. What is ft? E to the power 3t dt. So 0 to infinity, I can write e to the power minus s minus 3 t dt. Can I write this?
Yes, sir.
Now you integrate it. It will be e to the power minus s minus 3 t divided by minus of s minus 3, where limit for t 0 to infinity. Then again here, what is the criteria? Uh, means e to the power minus something into t. Whenever t you put t is equal to infinity, that tends to 0 if and only s is greater than 3, right? If that is positive, then e to the power minus something into t, whenever t is equal to infinity, that tends to 0. So here also the condition is s greater than 3. Fine. अगर s लेस देन 3 हो जाएगा तो ये e to the power में पॉजिटिव आ जाएगा एंड वो 0 नहीं होगा. So it will be, if you put infinity, then 0, and minus of, if you put 0, t is equal to 0, then it is this. So it is 1 by s minus 3 whenever s is greater than 3. Look, so we are taking Laplace transform of different type of function, and we are getting different type of function of s. Okay, in the previous case, if the function is 1, then we got 1 by s. If the function is e to the power 3t, then we are getting 1 by s minus 3. Similarly, you can try with a means polynomial type. If ft is equal to, say, t, if ft is equal to t, then what will be the Laplace transform you can verify. Like I'm giving you as an exercise, Laplace transform of t means ft is equal to t. Okay, if ft is equal to t, then what is the Laplace transform of ft? That means Laplace transform of t. Now, according to the definition, what it will be? 0 to infinity e to the power minus st into t dt. You can evaluate that integration easily by integration by parts. Fine, you try it. Now, see, as per the notation, we are writing fs is equal to Laplace transform of ft, right? What we can see that after taking Laplace transform, it will be a function of s, right? So what I write, fs which is Laplace transform of ft, means ft का Laplace transform लेने के बाद वो एक function of s हो जा रहा है. That fs is called Laplace transform of ft. Now, or we can write also ft is equal to Laplace inverse of fs, right? So here that capital Fs, it is called Laplace transform of small ft, and ऐसे अगर थोड़ा घुमा के लिखेंगे तो small ft, it is the Laplace inverse of capital Fs. Okay, that is called Laplace inverse. So these are the two major tasks. Given function of t, you have to find fs, or given capital Fs, you have to find small ft. See, now these are simple properties of Laplace inverse, means a function. Simple properties of a function. Uh, L of L inverse capital Fs. L inverse क्या हो जाता है? Identity mapping. So L inverse of capital Fs, that is capital Fs, and L inverse of L of Ft, that is Ft, small ft. Okay. So these are simple properties of that inverse function. Now let us come to linearity of Laplace transform. Do you know linear transformation? Do you remember? Linear transformation. In vector space you have studied, right? Linear transformation. You forgot.
Yes, sir.
Okay. So linearity property means T of C1 alpha 1 plus C2 alpha 2. It is C1 T alpha 1 plus C2 T alpha 2. So that is called linearity property. Fine. In any case, matlab in vector space also, in anywhere, that is the general case of linearity. So T of C1 is a constant, C2 is another constant. So T of C1 alpha 1 plus C2 alpha 2, it is equals to C1 T alpha 1 plus C2 T alpha 2. That is called linearity property of the function T. Now here also the Laplace transform, it follows linearity property. Okay, Laplace transform, it follows linearity property. What is the linearity property you see in Laplace transform? So here the function is L. Okay, L is the transform. L of A into Ft plus B into Gt. So Ft, Gt are two function of t defined for t greater equals to 0, and A, B are two constants. Then by the linearity property, it can be written as A into L Ft plus B into L, sorry, L Gt. That is called linearity property of Laplace transform. Means linear Laplace transform of linear combination of two function Ft and Gt, it is equals to A into Laplace transform of Ft plus B into Laplace transform of Gt. Now what is the application? Where do we apply this? Like if it is asked, find Laplace transform of say cos hyperbolic t. Okay, Laplace transform of cos hyperbolic t. So how to find it? Means Ft is equal to cos hyperbolic t. So Laplace transform of cos hyperbolic t is equals to, do you know the means formula for cos hyperbolic? In OD I told na? In OD I told, or some means it is in the first semester. It was in the first semester, right? Cos hyperbolic function. Do you know or not? What? Tell me.
So e to the power of x plus e to the power minus x, right?
Yes. Here it is t. The variable is t. So it is e to the power t plus e to the power minus t by 2. That is the formula for cos hyperbolic t. If it is written cos hyperbolic 2t, then e to the power 2t plus e to the power minus 2t by 2. If it is cos hyperbolic 3t, then it will be e to the power 3t plus e to the power minus 3t by 2. Okay. So e to the power t by 2. Okay, one line I am writing. Plus e to the power minus t by 2. Now a log 1 by 2 e to the power t plus 1 by 2 e to the power minus t. Can I write this?
Yes, sir.
Now is not it of the form a into ft plus b into gt? So what I can write? It is equals to constant can be written outside the transformation. 1 by 2 a log e to the power t plus 1 by 2 a log e to the power minus t. Like in the in differentiation also, na, you did these things. Constant always outside the you can take it outside the differentiation. Similar type. And constant means differentiation also follows the linearity property. ddx of fx plus gx. You can write ddx of fx plus ddx of gx. So have you got the application of this linearity property? Look, now you
Sir,
know.
can you tell it again?
See here, L of 1 by 2 e to the power t plus 1 by 2 e to the power minus t, right? So it
Yes,
is
sir.
of the form a into ft plus b into gt.
Yes,
Where
sir.
a half ft e to the power t, b half gt e to the power minus t. Now, if we don't know this formula, then we cannot write this because of the applicability of this linearity property. We are writing the last line a into L of ft plus b into L of gt. So 1 by 2 into L of e to the power t plus 1 by 2 into L of e to the power minus t.
Got it, sir.
Okay. Actually, in this line, I have applied linearity property. Now you know Laplace transform of e to the power t. Not always you have to use that integration formula. Okay. Don't think that every time I have to use that integration and then solve it. No, actually there are some tabular formula which you can use directly. So here also it is a tabulated function e to the power t and there are a formula for it. Laplace transform of e to the power t. Here actually you can compare with this. In whenever we took ft is equal to e to the power 3t, we got what? 1 by s minus 3. Now, if it is e to the power t only, we will get 1 by s minus 1. Fine. So there are some tabulated formula. I will show you. So Laplace transform of e to the power t that we can write directly. It is 1 by s minus 1. Okay. And Laplace transform of e to the power minus t, that is also a tabulated formula, tabulated function. We can write it. It is the function 1 by s plus 1. Now you can simplify it and you write what is the uh,
Yes, sir.
what is the function ultimately. It will be what? S plus 1 plus s minus 1. So it will be 2s, right? 2s and divided by a square minus 1. So ultimately it is s by a square minus 1. Right? So it is the Laplace transform of cos hyperbolic t. There is no tabulated formula for cos hyperbolic t, but by applying linearity property, we can find it. We can find the Laplace transformation of it, or it may be given in that form also. Okay, like what is the Laplace transform of 2 e to the power t plus sin t. So first of all, you have to apply the linearity property. 2 into Laplace transform of e to the power t plus 1 into Laplace transform of sin t. That is by the linearity property, right? Now it is tabulated. It is a tabulated function, and it is also a tabulated function. There are a formula for a Laplace transform of sin t, Laplace transform of e to the power t. So now you can write it, and you will get a function of s. Basically, I am showing that linear application of linearity property. Fine. So previously, they go. I have shown Laplace transform for the function 1, Laplace transform for the function e to the power 3t, and here also you can calculate Laplace transform for the function t. So now I am showing the tabulated formulas. Okay, which you have to remember. If you remember this formula, then you can solve every type of Laplace transformation problem. So see, actually, mm, from now on, no need to find Laplace transform of these functions by integration. You can directly write this. Okay, if it is asked Laplace transform of 1, it is 1 by s. I have shown by integration, is not it? I have shown from the definition also. Ft, if ft is equal to 1, what is the Laplace transform of ft? It is 1 by s. But whenever you are using that Laplace transform in a problem, don't no need to do that in no need to show that integration. Directly you can apply Laplace transform of 1, that is 1 by s. Fine. And they go e to the power at. I have shown for a is equal to 3, e to the power 3t, right? It was 1 by s minus 3. Now in general, e to the power at, the formula is 1 by s minus a. Okay, Laplace transform of e to the power at, it is 1 by s minus a. Laplace transform of 1, 1 by s. Now polynomial type. Polynomial type means one I have asked na, that you do it yourself. Laplace transform of that if t is equal to t, means by that by solving that integration you will get the Laplace transform of t. Okay, and what it will be by that integration, you will get 1 by a square. You check it by that integration 0 to infinity e to the power minus st into t dt. You do it, you will get 1 by a square. So that is also a tabulated formula. You have to remember Laplace transform of t, 1 by a square, t square factorial 2 by s cube, t to the power n factorial n divided by s to the power n plus 1. So no need to remember actually this. That is the general one. Na? So that general formula you remember, and then you put, if it is t, then you put n is equal to 1. If it is t square, then put n is equal to 2. So okay, are you getting? So that is the general formula, you can say general formula in case of polynomial. Laplace transform of e to the power n. What is the formula? Laplace transform of t to the power n, e to the power n, it is equals to n factorial divided by s to the power n plus 1. Fine. Here n is an integer. N is an actually rather n is a positive integer. n देखो n का वैल्यू क्या है 0 1 2 3 4 5 6. Then you can write this factorial notation. But if n is not an integer, then what you have to write? Like that in Bessel function ना गामा करके लिखे थे ना फैक्टोरियल को. Do you remember? Just 2 classes back, I think. Gamma of m plus nu plus 1 लिखे थे ना, m plus nu plus 1 which is equals to, if nu is integer then m plus nu factorial, and if nu is not an integer then you keep that form, gamma of m plus nu plus. So here n factorial. Now if n is not an integer, like if it is asked Laplace transform of t to the power 3 by 2, okay, so can you apply this formula? 3 by 2 factorial, it is not valid, right?
Yes, sir.
So in that case you have to apply the gamma function. So in general t to the power a, where a is any number, okay, maybe integer, maybe fraction, the form is gamma a plus 1. देखो इंटीजर के लिए ए फैक्टोरियल n मतलब वो क्या होगा, गामा n plus 1. If I want to write it in gamma form, it is gamma n plus 1 na? That is the generalization of this, s to the power a plus 1. So that is the more general formula. From this formula you will get this, you will get this, you will get this, you will get this also. Okay, तो अगर बस ये फॉर्मूला याद रखोगे, t to the power a, that is gamma a plus 1 divided by s to the power a plus 1. देन ये सब मतलब बाय डिफॉल्ट आ जाएगा. क्या फास्ट केस आएगा? फर्स्ट केस में a का वैल्यू 0, गामा 1, व्हाट इज द वैल्यू ऑफ गामा 1? गामा 1 means 1, right? And नीचे 0, s to the power 1. Yes, you will get the first one also. Are you getting?
Yes, sir.
मतलब तुम लोगों की सुविधा के लिए मैं बोल रहा हूँ कि यू जस्ट रिमेम्बर दिस फॉर्मूला. अगर सभी याद रख सकते हो तो बेटर है, बट इफ यू रिमेम्बर ओनली दिस फॉर्मूला देन you can find the Laplace transform of this above.
Yes, sir.
And that is the another type of function, e to the power at, Laplace transform of e to the power at, that is 1 by s minus a. Okay, now here a may be positive, a may be negative also. Now you think, if it is asked Laplace transform of e to the power minus 2t, then it will be what? By 6, it will be what?
1 by s plus 2.
1 by s plus 2, correct. Because a is minus 2 here. That is the formula. You can find Laplace transform of e to the power any power, means e to the power any value, by this formula. So these are one type of formula, that is another type of formula. Now 7. If ft is equal to cos or ft is equal to sine, these are other type, trigonometric function type. So Laplace transform of this cos omega t or Laplace transform of sine omega t. What are the formulas? देखो Laplace transform of cos omega t, it is s by a square plus omega square, and Laplace transform of sine omega t, it is omega divided by a square plus omega square. So in both cases denominators that is same, a square plus omega square, एक में ऊपर में a से, एक में ऊपर में omega. Okay, so how to remember? Actually you can remember by that sin s. Okay, मतलब साइन में s से शुरू होता है, तो इसका लैप्लास ट्रांसफॉर्म में ऊपर में s नहीं होता है. ऐसे भी याद रख सकते हो. These are the remembering techniques. Okay. Laplace transform for sin means ऊपर में s नहीं होगा. साइन का s से शुरू होता है, so ऊपर में s नहीं रहेगा. And no need to remember these two because you can derive it as I have shown now. In the Jamboard, I have shown how to derive the formula for cos hyperbolic, sin hyperbolic.
Yes.
Where? This one. I have shown cos hyperbolic t. Now, if it is cos hyperbolic at, means t is multiplied by a, then the formula will be e to the power at plus e to the power minus at divided by 2. Then everywhere it will be at, right? Then the formula ultimately here it will be a 1 by 2 1 by s minus a 1 by 2 1 by s plus a, and ultimately it will be s by a square minus a square, s by a square minus a square. तो देखो ये cos and cos hyperbolic डिफरेंस क्या है, माइनस है नीचे, है ना. हाइपरबोलिक में नीचे माइनस है एंड ओनली ट्रिगोनोमेट्रिक केस में लैप्लास ट्रांसफॉर्म नीचे प्लस. So these are some remembering techniques I am telling, so that no confusion is there whenever you are applying. So cos hyperbolic at it is s by a square minus a square, and sin hyperbolic at a by a square minus a square. So you can use these two formula directly also. Fine. And these 11 and 12 I don't recommend to remember these two because there have some formula, there have some means property. By using those property, you will get Laplace transform of these two. Okay, whenever means it is a multiplication of e to the power at cos omega t or e to the power at sin omega t. So you will get it by some property. I will show you. No need to remember this. So again I am repeating from the table which things you have to remember, which are the main formula. This formula number 5, 6, 7, 8. Okay. एंड अगर ये बाकी सबके सभी याद रख सकते हो तो वेल एंड गुड, मतलब कोई कंफ्यूजन ही नहीं रहेगा और भी टाइम कम लगेगा. बट देयर आर 4 मेन प्रॉपर्टीज, 4 मेन formulas. Okay. ओनली फॉर्मूला बेस्ड क्वेश्चन भी आता है यहाँ से, मतलब शॉर्ट क्वेश्चन. कोई एक फंक्शन ऐसे छोटा मोटा दे दिया, फाइंड इट्स लैप्लास ट्रांसफॉर्म or find the Laplace inverse. Here I am showing only ft is given, what will be the fs. Okay, sometimes fs is given, what will be ft means Laplace inverse. वो भी मतलब या मतलब पूछ सकता है. So in that case actually if the function of s it is 1 by s, its Laplace inverse is 1. Okay, Laplace transform of 1 it is 1 by s, then Laplace inverse of 1 by s will be 1, vice versa case. Okay, I have shown now in the Jamboard that if fs is equal to Laplace transform of ft, then ft is equal to क्या होगा, Laplace inverse of fs. That ft is called Laplace inverse of the function fs, and capital Fs is called Laplace transform of ft. So L of f, that is the column for fs. Okay, function of s, all the देखो second column all the functions are function of s. So if it is asked, say what is the Laplace inverse of omega divided by a square plus omega square. Okay, ignore it. I am giving you a particular one. what is the Laplace inverse of 1 by s minus 9? Can you tell me what is the Laplace inverse? So to find Laplace inverse, you just find the function of s in the second column. Okay, सेकेंड कॉलम में देखो ये कौन सा फंक्शन मतलब कौन सा फॉर्म से मैच करता है
e to the power 9.
this, right?
Yes,
That
sir.
fs is of the form 1 by s minus a. Then its Laplace inverse is e to the power at. Then a is what here? A is
Sir,
9.
3t.
No, 9.
Yes, sir, 9. Sir.
9. This. So that single table gives us the Laplace transform as well as Laplace inverse. Fine. Can you tell me what is the Laplace inverse of 1 by a square minus 1? First of all, you find the form in the second column.
Sir, sin t. Sin ht.
Sin,
ht.
yes, sin is this formula you see. If you take a is equal to 1, a is constant, a may be anything. So here the case is a is equal to 1. 1 by a square minus 1. So it will be sin h t. Okay. Now can you tell me what is the Laplace inverse of 1 by s cube? Tell me.
T to the power n.
T to the s to the power 3, 1 by s cube, I am telling.
सर ऐसा तो कुछ नहीं है
है. You have to manipulate something, means not directly it is given. Look,
So it will be 3 factorial by s cube.
it is not exactly that form, but you can see that 2 factorial by s cube, it is merely same. Just constant multiplied, right?
Yes,
Along
sir.
1 by s cube, that factorial 2 is multiplied. So what I can do, I can adjust a constant always. I am writing 1 by 2 factorial into 2 factorial by s cube. Can I write this? Now that you 1 by 2 factorial, you can write it outside the Laplace inverse. So 1 by 2 factorial Laplace inverse of 2 factorial by s cube. Now it is exactly that third formula. So it is t square. So t square by 2 basically. Fine. So Laplace inverse of 1 by s cube, it is t square by 2. Sometimes you have to adjust it. Okay. You have to
सर
adjust it by the constant. हाँ बोलो.
सर जो सेकंड वाला एस स्क्वायर माइनस वन होगा वो सर साइन एच टी होगा या साइन टी खाली होगा ना सर? ए तो वन है ना.
हाँ a1 है, but you see the formula, it is hyperbolic function. That is the formula for hyperbolic function.
ओके ओके सर, गॉट इट सर.
देखो टेबल अच्छे से देखो, ये साइन एच टी है एंड ये साइन ओमेगा टी है. These are two different functions. These are not same. It is hyperbolic and it is trigonometric.
यस सर, यस.
एंड साइन सिर्फ अगर साइन होता तो वो नीचे प्लस रहता, ए स्क्वायर प्लस वन होता तो वो साइन टी होता. देखो इफ आई राइट लैप्लास इनवर्स ऑफ 1 बाई ए स्क्वायर प्लस 1, then you can write sin t. It is not
साइन
sin
टी.
t.
यस.
Okay, do you get it? So to find Laplace inverse or Laplace transform, sometime you have to means adjust it by constant. जैसा अभी मैंने दिखाया Laplace inverse of 1 by s cube. Okay, in the next class I will tell you S shifting theorem, and by using S shifting theorem we will get these two results. Okay, so no need to remember these two again. I am repeating 11 and 12. You can by applying S shifting theorem on sine and cos, you will get these two formulas. Very simple. Before that, you have to understand that shifting theorem, what it is telling. So in the next class I will tell you. That's all. देखो ये प्योरली फॉर्मूला बेस्ड है, छोटा छोटा फॉर्मूला है, वो फॉर्मूला को याद रखोगे एंड प्रॉब्लम सॉल्व करो.
Yes, sir.
टोटली एल्जेब्रिक, सभी एल्जेब्रिक कैलकुलेशंस.